Hello, my name is Dinko Klobuchar and this is my first eurorack tutorial. Today I want to share some techniques for generating melodic structures using low-frequency oscillators and quantizers. Let's start with creating our base LFO signal. I'm using Shapeshifter because it can offer many different waveforms and we can also morph through different shapes. That will be very useful later on to create animated variations. But any basic LFO can be used. It is always helpful to start with sine wave or some other simple waveform because it's much easier to test with. We will sample the values from our sine wave using sample and hold to create CV signal that will become our pitch data. We also need a trigger to run sample and hold. I will use square LFO as our main clock. We will also need some copies later on, so let's use a mult straight away. Let's visualize sample and hold output. This red signal is now showing sampled values of the sine wave. This is a very crude representation of the sine wave, but our clock is controlling the sample rate. So, as we increase frequency of the clock, resolution of output signal is also increasing. Since we want to create discrete values to run oscillator pitch, we will decrease the sample rate and use it as tempo for our melody. Let's also hear resulting values by patching this to 1 volt per octave input of the oscillator. As you can hear, the range of resulting values is quite big. On oscillator display you can see that it goes way below audible range. Oscilloscope is also showing voltage values going down below zero. To make this more usable, we need to be able to control this range. Let's move original signal to the second oscilloscope channel to make it blue. And process this signal through offset and attenuator. Attenuating the signal will shrink the range of pitches. And using offset we can push the range up and down. For now, we can modify the range and we can control the tempo. Now, this might not be obvious at the moment because clock and our base LFO cycle are by chance really close. And this might seem as a loop, but it's really not. If you listen carefully for a few cycles, you will hear that the pitches are slightly drifting with each cycle. Now you can hear how we are slowly going down with each cycle, which is really nice, but very often you will want to create loops. To create a loop, we need to reset our base LFO every time we want loop to restart. And to reset some oscillator, you need to provide sync signal. Let's make it longer by dividing the clock. If you apply smallest change to the pitch of base LFO, you can create completely different loop. Now we can quickly test huge amount of different sequences simply by modifying LFO frequency and adjusting the range using offset and attenuator. Notice how pitch values now remain consistent on every repeat. You can create really nice microtonal and mathematical sequences with this setup, but we will now restrict the set of frequencies to chromatic scale. To do that, we can use Quantizer, which will take our pitch CV and force it onto a grid of defined pitch values. Let's exit the loop for the moment. Now we are playing just notes from C major scale. You might notice some glitches, and that is because some values we provide are on the border between two notes. This is easily fixed by providing the trigger, which tells when to sample the input value, much like sample and hold. You might also wonder why did I use sample and hold at all before Quantizer, but that will become clear once we start transposing and adding second voice. We can restrict our set of frequencies even more by defining a 4-note scale. Lowering the frequency of base LFO, we can easily hear all notes that can appear in our sequence. Let's again create some loop. Setting frequency low, we can create simple arpeggios. And higher frequencies bring more movement to the sequence. Make small variations but keep general movement of the sequence, we can modify LFO shape slightly. Using Shapeshifter, we can morph between different shapes. It is now easy to create different sequences. Setting a longer loop, modifying the range using attenuator and offset. We can also animate morphing of the base waveform using slow-moving LFO. That will slowly change basic sequence over time. Let's modulate a bit faster to make variations more obvious. Let's try some other waveform. Modify the range. Shorten the loop to make it really simple, so we can see how this morphing adds complexity to the sequence. This creates seemingly long sequences, but it's really just modifying a short loop. This way we can keep general movement of the notes, but slowly animate the changes. Let's modify sound a little bit to make it more interesting to listen. When using quantizers, it is a good idea to use gate output post-quantizer rather than original gates, because it takes a little bit of time to process incoming voltages, and if you are triggering an envelope, you could sometimes hear previous note come through the VCA. Using gates generated by the quantizer solves this problem. Let's also duplicate our pitch CV so we can use it to modify filter cutoff frequency. And let's switch to square wave to make it more interesting using a filter. Next interesting thing we can do is transpose the sequence. For this I will use make noise pressure points and transpose input of the quantizer. Let's create few CV values first. Now we can use our divided clock to sequence the transposition. I modified loop parameter instead of sequencer clocked by mistake, so let's make it slower. Let's try creating a bit more interesting sequence. can add a second voice, and to make it more interesting, we will make first sequence influence this new sequence. To do that, we will use copy of the first sequence before Quantizer. We want to use this signal rather than processed signal because Quantizer is currently producing transposed pitch values. To make this, I will use polarizing mixer. First channel will be left blank because it can be used as offset. Second channel will be original signal of the first sequence. And third channel will be another LFO from Shapeshifter. Patch the mix to second sample and hold. And get another trigger source. And pass this to Quantizer. We also need to trigger the Quantizer, so let's duplicate the same trigger. And another voice is ready to be used. Now, on the macro level, controlling the range of the first voice, it will also affect the second voice. For example, pushing the first voice lower, the second voice will also become lower. But of course, you still have all separate controls for the second voice. In conclusion, we built a system that we can use to create melodic structures for two voices. Second voice is influenced by the first voice, which adds another layer of complexity, and also creates organic controls on macro level. We also have simple UI that can be used to easily generate complex pitch CV without defining a single note using sequencers. Let's go through the controls one more time. LFO controls the tempo. We have control over loop length. To quickly create different patterns, we can use frequency of main LFO and select waveform shape. To create evolving melodies and subtle variations, we can smoothly animate LFO shape. To control the range of produced notes, we can use offset and attenuator. These controls also affect notes produced for the second voice. We can control offset of the second voice, how much the first voice influences the second voice, and control the range of notes for the second voice. We can define a scale, and finally we can transpose using a sequencer. To take this further, consider creating more voices by mixing two sequences, inverting and resampling and modifying in different ways to create a generative system that can be controlled on macro level. You can use two extra CV outputs from the sequencer to control sequence tempo and loop length to develop rhythmical variations. Also consider adding another sequencer to create precise compositions by sequencing both LFO pitches. I hope you found this tutorial interesting. Thanks for watching.